Okay, so as you know, we completed some portion of the kinematics. We discussed vectors as well. But as per your spreadsheet that we had shared with you, you guys came up with the thought that we should be discussing something about the charges, the current, electricity, and magnetism with you. So here I am. I'm going to discuss one unit from AP Physics 2, okay, and that is electrostatics. Is that fine? That will be electrostatics. And now when we talk about electrostatics, statics, all of you know that statics means things are at rest, isn't it? And electro means charges, okay? So in this unit, what we are going to discuss is charges, their properties, but those charges have to be at rest. Is that fine? So first of all, we need to understand what is a charge. Can anyone tell me what is a charge? What is a charge? Yes. What do you mean by charge? What do you understand from charge? Yes. Negative and positive charges. What do they do? Anything else? See, if you observe carefully, everything created by Allah subhanahu wa ta'ala is neutral, isn't it? The reason for that being, if you go to chemistry, if you look at the structure of the atom, it has protons and it has electrons, and in every atom, be it of sodium, be it of magnesium, be it of iron, anything, the number of protons and the number of electrons are equal, isn't it? Therefore, matter is neutral. Is that fine? But if there is some disturbance in the equilibrium, if you happen to increase or decrease the electrons or the protons over an atom, it develops a property. That property that an atom develops after there is inequilibrium between the positive and the negative ions or the electrons and the protons, then we say that this atom has gained something called as charge. It is a property which is there because the equilibrium of the protons and the electrons has been disturbed. Is that fine? Clear? So, the first important thing is, what is a charge? Electric charge is a property of, it's a property. It is an intrinsic property which gets generated when the protons and the electrons, they are unequal in a body. Is that fine? Whenever they are unequal, we say that the body has something called as charge. Now, this charge can be positive, it can be negative as well. Okay? It can be positive, it can be negative as well. Negative charge is the property of electrons, and the positive charge is the property of protons. You need to understand what is happening. When a body has more number of protons, we say that it has positive charge. When a body has more number of electrons, we say that the body has a negative charge. But first of all, you need to understand, positive and negative are just sign conventions. What do you understand from positive and negative? Positive means, if there is a body, it behaves in a certain way, okay? And then there is another body, it behaves in an opposite way. Then if this is positive, this is negative. If this is up, this is down. If this is right, this is left. That's it. So positive and negative is just the sign convention given. Is that fine? Clear? So when a body has more number of protons, we say that it has positive nature. When a body has more number of electrons, we say that it has negative nature. Is that fine? Clear? One more important thing about this charge is that charge is conserved. Now there is, what do you mean by conservation? That means, for example, there is a body and it has some charge. Now, you cannot create more charge over the body. You cannot, destroy the charge present over a body. what you can do is you can take some charge from it and transfer it to some other body. Is that fine? So charge can be transferred. Charge can be, but it can neither be created nor be destroyed. Fine? But do you know there are two exceptions to this general rule or law of conservation? There are two exceptions. One is, remember this thing, this is something of very importance, very much importance. The thing is, one is called as pair production. And the other is called as metal annihilation. Understand, very important. When you talk about conservation of charge, what did I say? Yes, there is a body, say for example, this body is neutral, okay? If I take away 2 electrons from this body, if I take away 2 electrons, what will happen? There is an equilibrium of protons and electrons in this body, isn't it? But when I take away 2 electrons, now this body will have 2e but positive charge, isn't it? Correct? So it is not the creation of charge, it is the transfer of charge. Is that fine? When this body is losing 2 electrons, so it will have 2 positive charge. Is that clear? So charge has not been created, it has been transferred. Is that clear? But similarly, for example, if I give back 2 electrons to this body, it will be neutral. So charge will not be destroyed, but it has been transformed. Fine? But to this law, there are 2 exceptions. One is the pair production, and the other one is matter annihilation. Do you know, in chemistry, if you want to represent your electron, you represent your electron something like this, electron. Yes? An electron doesn't have any mass, but it has a negative charge. Is that fine? Now remember, Allah subhanahu wa ta'ala has created everything as pairs. Right? If there is matter, then there is a possibility every time you will find its antimatter. So when there is electron, there is something called as anti-electron. It is a particle which will have the same mass as that of electron. Okay, but its charge will be positive. This is not a proton. This is an anti-electron called as a positron. What do you call it? What do you call it? Yes, positron. Very important. An electron, when it sees its antiparticle called as the positron, it combines with it. The moment it combines with it, it gets converted into gamma radiations. See what is happening? Gamma radiations. Energy. What was this? This was a particle, isn't it? This particle has charge. What is this? This is again a particle. This has mass, this has charge. Fine. But when these two combine, what do you see? Nothing. There is no mass. There is no charge. Law of conservation of mass violated. Law of conservation of charge violated. Because this is purely energy. Is that clear? This is called as matter annihilation. Matter annihilates into energy. This happens as per, if you remember, E is equal to delta mc square. Have you heard about this equation before? I told you energy and mass are one and the same things. It was mass, it has been converted into energy. There is no charge. This is not transfer of charge. This is destruction of charge. Understood? So this is completely against the law of conservation of charge. Is that fine? That is why physicists say if a matter finds its antimatter, it will be lost. That is why physicists also say you should not hug a person, you should not handshake with the person, you should not kiss the person. Reason is What if that person has your anti-particle, has your anti-matter? The moment you hug him or her, what will happen? When you hug, you will get converted into energy. Khalas, there will be nothing left. Understood? So be very careful from today onwards while you shake hands. So this is an exception to law of conservation. Similarly, there is one more exception, that is the pair production. So what will happen? Sometimes what happens is this gamma radiation, okay, gamma, it is chargeless, it is massless. It gets converted into an electron and a positron. Is that fine? So see, charge has been created. Because now you will say, sir, this was neutral, so this charge has been transferred. I understand your concept, but the thing is, this does not have mass. And without mass, charge does not exist. Is that fine? Charge only exists whenever there is mass. So when there is no mass, this is energy. It has no mass. How is it possible that it has created mass and that mass has charge? So this is an exception to law of conservation. Is that fine? Okay, one more important thing. Charge is quantized. See, what do you mean by quantization? Here in UAE, whenever you have to exchange money, you exchange it in the form of dirhams, isn't it? Which is the smallest dirham that you have? No, smallest dirham, it is 1 dirham, right? So I cannot break that into 2 pieces and say this is half dirham. 50 fils is not, it's not 1 dirham split it into 2 portions, right? We have a different figure for that. 50 fils is some other coin, right? So whenever we exchange, I give you 1 dirham. I'll give you 2 dirhams. I cannot give you 1 dirham and the other half dirham. I cannot give a fraction of some other dirham, isn't it? Whenever I am exchanging money with you people, it will only be in multiples of 1 dirham. 200 dirhams, 500 dirhams, 600 dirhams, 10 dirhams, 20 dirhams, whatever. But that dirham is the multiple of 1 single dirham, isn't it? So money is quantized. Is that clear? For example, if you talk about the table of 2, first is 2 1 are 2, right? 2 2 are 4, 2 3 are 6. So everything is being multiplied by 2, isn't it? Isn't it? Similarly, when charge is being exchanged, it gets exchanged in the form of multiples of electrons. Is that fine? So whenever I give charge to you, you give charge to another body, it will be exchanged in the multiples of an electronic charge. Because the smallest stable entity which has charge is an electron. So we can exchange 1 electron, 2 electrons. We cannot exchange 2.5 electrons. We cannot exchange half electron. We cannot exchange 1.5 electron. We can only exchange either 1 electron or 2 electrons or 3 electrons or 4 electrons. Is that fine? So the number of electrons multiplied by the charge of the electron will be the total charge present on a body. So if you talk about the equation is this. The equation is this. The net charge on a body, it is equal to plus or minus, depends on the nature, be it the electrons or the protons, n times the electronic charge. This is the quantization equation. So E is the charge of 1 electron. Can you tell me what is the charge of 1 electron? Anyone? Yes? What is the value of E? What is the charge of an electron? No, the charge of electron is 1.6 multiplied by 10 raised to the power -19 coulombs. This is the charge of an electron. Okay, it's very small. So whenever the charge is present on the body, it will be in the multiples of the electronic charge. Is that fine? 2 electrons, 3 electrons. Now this n, this can be 0, this can be 1, 2, 3, 4, so on and so forth. It cannot be 1.5. exchanging 1.5 electrons. You cannot exchange a fraction of an electron. No. The smallest possible entity that has charge and is stable is an electron. So remember, only electrons are exchanged. The currency of exchange of charge is the electron. The currency of exchange of money is dirhams. Similarly, the currency of exchange of charge is electron. Is that fine? Yeah? This is thus we say charge is quantized in multiples of E. Is that fine? So charge is quantized. Something that is quantized can only be an integral multiple of some number. Here the number is the electronic number. Okay, the electronic charge. Multiplied by n. N is the integral multiple. Fine? So this is the concept of charge. Next, charge is only due to the flow of electrons. That's what I told you. See, when you talk about an atom, you know that the electrons are revolving around the nucleus, right? The protons are present within the nucleus, so protons never get exchanged. Only electrons which are present in the shells have the tendency to go out to come back. Is that fine? So electrons can be exchanged, protons cannot be exchanged. So the currency of exchange is only the electronic charge. Is that fine? Clear? No doubt in this? Okay. Now tell me, how do you exchange positive charge then? If a body has, for example, two positive charges, how do we understand that it has developed two positive charges? A body has two negative charges. Yeah, exactly. So understand. If a body has positive charge, it doesn't mean positive charge was given to it. No. Actually, it has lost two electrons. If a body has more electronic charge, say, for example, there is a body which has 5 negative charge. So it means it has gained 5 electrons. Right? If a body has 5 positive charge, it doesn't mean it has gained 5 positive. It means it has lost what? 5 electrons. Clear? Because the currency of exchange is only electron. We cannot exchange protons. Understand this. Exchange happens in terms of electronic charge. That's it. Okay, now there is one more important thing, that charge is able to show when electrons move, okay, which readily occurs in a conductor. Now, conductors, you see that current flows very fast, isn't it? The reason is these electrons have the tendency to flow very quickly in terms of conductors. Okay? These electrons do not flow at all when you talk about an insulator. These electrons have, some intermediate conductivity when you talk about semiconductors. So very far, if these charge is called as the electrons travel very fast, then the substance is called as a conductor. If these electrons travel, in between somewhere, slow but not very slow, fast but not very fast, then the material is called as semiconductor. And if these electrons do not travel at all, you call that as an insulator. Diamond is an insulator, okay? Wood is an insulator, okay? It is not that electrons don't travel. They take a lot of time to travel, so we ignore their conductivity. Is that clear? Okay, objects with... So what is a conductor? In a conductor, what happens is electrons move very freely, okay? So it has low resistivity, its resistance, its opposition to the flow of charges is very less, okay? But it has high conductivity. Fine? And remember one important thing, that whenever charge is given to a conductor, it always resides on its surface. Say for example, you have a conductor, okay? You have a conductor. If I give some charge to this, now this charge will be present on its surface. Here. It will not go inside. It will not go inside. It is always present. In a conductor, whenever charge is given, it always is present on its surface. It doesn't go inside. It doesn't go inside. Because, understand, very important. See what happens. For example, this is the body and I'm trying to give charge to this body, okay? If the charge is inside, the charge will be very close to each other, isn't it? But once the charge is very close to each other, don't you think there will be more repulsions? Yes? When there are more repulsions, the charge wants to go away. So it wants to keep itself at the maximum possible distance from the other charge. So what happens is, if the charge is present here, it goes out, it comes to the surface. On the surface, it has more space. So when it has more space, repulsions are minimized. Electrostatic pressure is minimized. Therefore, it is safe. But when it is inside, it is under too much stress, it is under too much pressure. So it doesn't stay there, it just comes out. Is that fine? So whenever charge is given to a conductor, it always stays on its surface. Fine? Okay. Then we talk about an insulator. As I told you, insulators, they do not conduct. Their electrons are not free to move. Therefore, we ignore their conductivity. Their resistivity is high. Okay, their resistivity is high, and their conductivity is low. Fine. So an insulator can have charge polarization due to. Okay, sometimes what happens is, when you talk about insulators, generally speaking, they are not conducting, okay? But sometimes what happens is, you can polarize them. Then they are called as dielectrics. What are they called? They are called as dielectrics. Dielectrics. So sometimes what happens is, there is an insulator and it starts to conduct. How? The method is called as charge polarization. Okay? What do? You apply some external force, and all the atoms inside, all the electrons inside are polarized. They were randomly, somewhere here, somewhere here, somewhere up, somewhere down. But the external field is so strong, it causes their alignment in a single direction. Now all of them will be directed like this. Fine? That's it. So I'll show you a diagram. Like for example, there's a body, is an insulator. Why? Because see what is happening? It has atoms inside which are randomly oriented. Okay, positive, negative, positive, negative. Okay, something like this. But once the external field is applied, orientation takes place. And that orientation does this. See what happens now? After orientation, every atom is like this. Negative, positive. Negative, positive. Negative, positive. Negative, and positive. So this is orientation. Now this is called as polarization. What is it called? Now this polarization sometimes helps these dielectrics to conduct. Otherwise they cannot. This is the general random structure. There is randomness. They are not aligned. They have any random direction of the atoms. Fine. So that is why they do not conduct. But if the external field is very strong, then the alignment takes place. The orientation gets rearranged. There is a single orientation, and due to which they can conduct. Is that fine? That is it. That is something about charge. That is something about quantization. That is something about the conservation, and that is something about the substances in which charges can flow. If charge flows very easily, we call it a conductor. If charge doesn't flow at all, we call it an insulator. Fine. But if it has intermediate conductivity, not very high, not very low, okay, then it is called as a semiconductor. And semiconductor is something which is in your mobile phones. Intermediate conductor. Fine. So intermediate, I will use the term intermediate for semiconductors. Semiconductors. So these conductors have intermediate conductivity. So that is it. Fine. Any doubt in charge? Yes. So understood what is the charge? Charge is a property. Don't say charge is positive or negative. No. Charge is a property due to which bodies show attraction or repulsion, due to which bodies generate electric and magnetic fields. Okay, it is a property. But how does this property come to a body? It comes because the equilibrium between the protons and the electrons gets disturbed. If there is a body, it has equal number of protons and electrons, it is neutral. So there is no charge. Fine. But once this equilibrium gets disturbed, the positive is more, electrons are less. Now this body has charge. Sometimes this happens. Electrons are more, protons are less. Again, it has charge. So this charge is negative and this charge is positive. And now what happens to this body because of charge? Now this body can attract or repel other bodies. It develops this property, this tendency, only after it acquires charge. Okay? Before that, it doesn't have it. But after it acquires charge, it can attract or repel other bodies. Write it down. Charge body. Write it down. Charge is an intrinsic property of matter. Charge is an intrinsic property of matter. Intrinsic. Intrinsic means it is present within. I-N. What? Intrinsic. Charge is an intrinsic property of matter, due to which a body can attract or repel other bodies. Okay? Full stop. Due to charge, a body can generate, electric and magnetic fields. Due to charge, a body can generate electric and magnetic fields. Is that fine? Clear? Are the properties clear? Charge is quantized, law of conservation of charge. Okay, exceptions as well. Is that fine? Okay. Now, after this, we talk about some fundamental forces of nature. You copied everything? You copied this concept of pair production and matter annihilation? Yes? Copy this. These are the exceptions to law of conservation of charge. And the concept is there. Done? Yes? Okay, I talked about the fundamental forces of nature. Can you tell me what all forces do we have? What forces do you know about? What are the fundamental forces in nature? Yes. Gravitation. Okay. Anything else? Yes. Magnetic. Anything else? Yes. Electromagnetic. Okay. What else? Which is the strongest force in nature? Who said that? You? If the gravitational force is between, yes, it's between what? Gravitational force is between two bodies, right? Is the gravitational force between you and me? Why? Am I not a body? No? So are you not a body? So if we are two bodies and if there is gravitational force, then why don't you come and stick to me? See, understand. The fundamental forces of nature. We have four fundamental forces. How many? The first fundamental force in nature that we see is the gravitational force. The gravitational force, remember, is the weakest force. It's the weakest. If it was strong, do you think you people would be there and I would be here? Not possible. Someone in America, I love her or him. Because of gravitation, they should come here. Isn't it? It's a very weak force, but very important, it is a long range force. Okay? So it exists between two bodies because of the exchange of particles called as the gravitons. Actually, two bodies. See, when I throw this up, it is the gravitational force which pulls it back. Do you know why? Because Earth has a lot, is heavy, isn't it? It is a celestial body. So it can do this. But it is a weak force. This force has very less value when we talk about light bodies. So when I asked Salim that why isn't there the gravitational force? There is gravitational force, but that force is very weak. Why? Because our mass is not high, it's less. Is that fine? It is a long range force. Someone in America has gravitational force with me. And remember, it is attractive. It is a loving force. Two bodies are always in love with each other because of the gravitation. They cannot repel. It is always what? Yes? Attractive. Is that fine? And this force exists because of the exchange of, yes, gravitons. These are the particles that are exchanged between two bodies. Fine? Is it clear? Then there is one more force, yes? So there is a force called as the weak nuclear force. Now, when you talk about the weak nuclear force, this is a short range force. This is a short range means it will not operate beyond the size of the nucleus. The size of the nucleus is very less, isn't it? What is the size of the nucleus? Yes, 10 raised to the power -14 meters. Okay. This is how small your nucleus is. Beyond this value, beyond this distance, this force doesn't exist. It's a very small force, short range force, but it is stronger than the gravitational force. It is seen when there is beta decay, when the electrons come out from the nucleus, when the positrons come out from the nucleus, when there is alpha decay. Okay, it is seen in that decays. Fine? Yes? Yeah? Attractive. The gravitational force is only attractive. Okay? It is attractive, and one more thing, it is because of the exchange of gravitons. The particles which are exchanged. Actually, do you know how does gravity operate? See, I'll tell you. This mass wants this particle called as the graviton. I also want the particle called as graviton. Okay? So because both of us love this particle, indirectly we come close to each other. Understood? So it is the exchange of the gravitons which does this gravitational force. Now we talk about this weak nuclear force. It is the short range force. Okay? And it is seen because of the exchange of Z and W bosons. Z and W bosons. These are the particles which are exchanged in beta decay. Now there is a phenomena called as the beta decay. Okay, in this phenomena we are seeing that the neutrinos, antineutrinos, the positrons and the electrons are formed. Okay, and in this the exchange particle is ZW boson, and this particle is responsible for a weak nuclear force, and it is only seen within the size of the nucleus, not outside it. Fine. Then there are much more stronger forces called as, yes, bosons. Z and W bosons. They are the name of the particles. Like we have gravitons here, we have bosons here. Okay. There are two types of bosons, Z and W bosons. Fine. These are exchanged when there are weak nuclear forces. And weak nuclear forces only operate in beta decay. Fine. Okay. Next, we talk about the electromagnetic forces. Electromagnetic forces. Now, electromagnetic forces are long-range forces. Okay. Not very long range, but just long range. Okay. These forces are because of the exchange of particles called as the photons. You know something about photons? Yes? They are the packets of energy of light. Okay? So it is because of these photons that electromagnetic forces operate. They are stronger than the weak nuclear force. Fine? They are long range as well. Yeah? Then we have the strongest forces in nature. Strong nuclear forces. Yes. Strong nuclear forces. Electromagnetic is, it is long range. Two particles are here. It depends on the strength of the charge. Okay? It depends. It's not short range like this, but it is long range. Okay? Then we have strong nuclear. Now, strong nuclear is again short range, present within the nucleus. Now, it is because of this strong nuclear force that within the size of the nucleus, proton and proton attract each other. What is proton? Positively charged. Another proton is also positively charged. But these two positively charged bodies cannot be present in a single space. How is it possible? It is possible because of these forces called as strong nuclear force. Is that fine? Yeah. Strong nuclear forces are present within the nucleus. They are short range, operate within this distance, okay, 10 raised to the power negative 14 meters. It is because of these forces that protons are held within the nucleus. Fine? Now these forces operate because of a particle called as meson. Fine? Meson. Because of this force, the protons stay within the nucleus. Otherwise, protons are repelling, right? But they still stay inside. Why? Because strong nuclear. They are very strong. They are the strongest forces in nature. They are the fundamental. Now, someone will come, sir, there are tension forces, there are viscous forces, there are this and that force. All of those forces will be clubbed in some category. But the basic are four fundamental. Okay? Rest, you know about friction, you know about, say for example, you talk about viscous force, you talk about drags. Meson, yeah. Meson is the particle that is being exchanged. See here, graviton. Here, ZW boson. Here, photon. And for the strong nuclear forces, you have the meson. And this meson is of three types. How many types? We have pi positive, pi negative, and pi. Three particles, three types of meson. These are exchanged within the nucleus. So understand, actually what is happening, there was a scientist called as Yukawa, okay? What he did was he tried to explain the theory, the meson theory. You know what he said? He said there are two dogs, okay? Two dogs. They're fighting over a single bone. There are two dogs, they're fighting over a single bone. They'll always fight, isn't it? But how do you keep them intact? How do you keep them together? And they should not fight. Is it possible? So he said, yes, it is possible. He said, no. He said, no, we will not have two bones with a single bone. So what he said was, he will keep the bone one side in the mouth of one dog and the other side in the mouth of the other dog. Now they cannot fight. Similarly, this meson is working between two protons. There are two protons wanting to be close to this meson. Therefore, they do not repel. Both want the meson. Is that fine? And therefore, they don't fight. That is the meson theory given by Yukawa. So, this is the strongest force. And if yes, positive, negative, and neutral. Pi zero. Fine. So, if you talk about the ratio, if you talk about the magnitude of these forces, I will give you an idea how strong is the gravitation of the nuclear force. The nuclear force is 10 raised power 40 times stronger than the gravitational force. 10 raised power 40 times the nuclear. Okay? The strong nuclear, strong. So I'll write the ratio. So it is 10 raised to the power 40 to 10 raised power 39 or 36, something like this. Then we have 10 raised power 25. And then we have 1. See, this is the ratio of the four forces. This is gravitational force, the weakest force. See how weak is it? The weak nuclear is 10 raised to the power 25 times stronger than the gravitation. Electromagnetic force is 10 raised to the power 36 times stronger than the gravitational force. And the strong nuclear force is 10 raised to the power 40 times stronger than the gravitational force. See how strong is the nuclear force. It is this nuclear force, there is one more particle. Have you heard about Higgs, Professor Higgs? He was in the news some months back. He passed away. He was a professor at University of Edinburgh, Ireland. Okay? He discovered a particle called as gluon. Do you know why he named it gluon? It is something, it has this word here, glue. Glue means something that can fix things, right? So as per him, the nucleus is there, it is intact because of the exchange of these particles called as the gluons. Okay? And he called them the glue of the universe. Why? Because in universe, on Earth, everywhere, there are atoms. And for all these atoms to exist, they must have what? The nucleus, right? And that nucleus can only be present when there is a glue. And this glue is the gluon. Is that fine? And it is because of this gluon that the universe is intact. Therefore, he calls them the glue of the universe. Okay. So is there any doubt in the forces and the charge? Whatever was discussed? Fine, is it clear? Now we have a question. So tell me, out of positive and negative charge, which charge travels? Which charge can move? Negative charge. Very good. Now there's a question. There's a question. You need to understand this one. Two separated identical conducting spheres are charged. There are two spheres. Both are conducting. They are separated, but they are charged. One is charged with 4 microcoulombs positive, and the other is charged by 12 microcoulombs but negative. Right? So I'll draw the two bodies, for example. There are two bodies. One is this, and the other one is this. They're symmetric. One has how much? 4 microcoulombs, and the other has minus 12 microcoulombs. Okay? The question is, the spheres are allowed to touch. Now we are bringing them close to each other. Okay? Describe the resulting movement of the electrons. Tell me what is going to happen. Yes? See, understand, this is plus 4 and this is minus 12. What will happen? Minus. So when I get them close to each other, bring them closer to each other, what will happen? Negative 8. So one will be negative 8 and the other? Sure. What do you think? Yes, agreed. Any idea what will happen? Rauda, any idea? Yeah, you. Oh yeah. Anything else? Anyone else? Any idea what will happen? Negative 16. See, you need to understand. Out of these two bodies, one body has more charge, other has less. Is it? So what is the total charge in the system? Total. One is 4 and the other has negative 12. Understand what is happening. Positive 4. Why does this body have positive 4? Because it has lost 4, isn't it? That's why it is positive. And this body has gained negative 12. That's why it is negative, right? So what will happen is charge sharing will take place. Now charge sharing will take place in such a way, because these two bodies are symmetric, they are identical, they will keep the same charge, both of them. How is that possible? So what will happen is, first we calculate the net charge. Okay? Net. So what is the net charge? Net is 4 minus 12. And that is how much? Isn't it? Now, because these two bodies are symmetric, it is simple. This body will have negative 4, and this body will also have negative 4. Is that clear? Both the bodies will have negative 4. Because the total charge, understand, we just said charge is conserved. So the total charge before was negative 8. When they are in contact with each other, the charge will be shared between the two equally. Reason for being equal is they are identical. Is that fine? If they were not identical, the charge would not have been same. But because they are identical, they'll keep the same amount of charge on both of them. So because we have a total of negative 8, negative 4 with one and negative 4 with the other. Is that fine? Is it understood? No doubt in this? Okay. Okay, then we have one of the most important laws that is called as the Coulombs law. There was a scientist in 1671, I guess. His name was Charles Augustin de Coulomb. He talked about the force which exists between two charges. Yeah? Charge zero? What? Yeah. Yeah. So, he says that if there are two bodies that have charge. Say for example, there are two bodies. One has charge Q1 and the other has charge, say for example, Q2. Okay. Q1 and Q2. Okay. And these two bodies are separated by some distance. These two bodies are separated by some distance r. So it is simple. If the charge on both of them is positive, then they will repel, right? And if one is positive, other is negative, they will attract, isn't it? The question was, by how much force? What is the value of that force? So this guy, by the name Charles Augustine de Coulomb, Charles Augustine de Coulomb, comes to our rescue. He said that the force between these two bodies is directly proportional to the product of the charges. Okay? And he also said that this force is inversely proportional to the square of the distance between the two. So that means if you keep them far away, the force will be less, and if you keep them very close, the force will be more. Fine? And when you combine the two, you will get something like this. Force is directly proportional to Q1, Q2 upon R square. And if you want to remove this proportionality, you can introduce a constant, and the value is this. F is equal to some constant, let it be gamma, Q1, Q2 upon R square. This is the Coulomb's law for the force between 2 point charges. If there are two charges, there will be values will be given, distance will be given. You need to know the value of gamma. You can find the force between the two charges. Is that fine? The gamma, the constant here, has a value of 9 into 10 power 9 Newton meter square per kg square. This is the value of this gamma. Is that fine? Remember the value, remember the expression, use it for the calculations. That is it. The easiest thing that you can do. This is called as the Coulomb's law. Okay? What? Newton, this is the unit. Newton meter square per kg square. Okay? Fine? And this force will always act along this line, joining the two bodies. This is the direction of the force. It can be attractive, it can be repulsive, depending on what is the nature of the charge. If they are same, similar nature, repulsion, opposite nature, attraction. Is that fine? Okay? Now we have a question. You can take a picture and try to solve. Sometimes in a single system you have several charges, then at that time you can use the principle of superposition. Okay? Now the superposition is nothing. At a time you take two charges, then evaluate the force, and then you will be able to calculate the net force. Okay? See, there are two bodies. The charge is given. On A we have 70 microcoulombs. On B we have negative 80. Fine. So the question is, what is the mass of the sphere? And the angle is also given 30 degrees. So this is 30 here. So actually what is happening is, this body has some charge. Initially the string will be straight, right? But the moment A body is here with positive charge, what will happen? A is positive, B is negative, so they will start to attract, right? Now because B can move, so B is going towards A, right? So this angle here is 30 degrees. The question is, what is the mass of B? What is the mass? Anyone? Can you do it? F is equal to You need to think a little bit more. You have the distance? No, the distance is not given. R is not given. The distance is not given. Okay. Because he has given you 30 degrees. Yes. Any idea what you will do? So, understand what will be our approach to solving this question? See, initially, when you talk about the string here, this string will develop tension, right? Is it? Is it or is it not? So this tension, which will be developed in this string, will have two components. One component will be here, if you remember vectors from yesterday, the previous classes. And then we will have one more component like this. Now, because this angle is 30, this also will be, right? Why? Alternate interior angles, right? So I'll draw the diagram here. There is a body A, and there is a body B. This body is connected with the wall, so there will be some tension in the string. Now, because this angle here is 30 degrees, so this angle will also be 30, right? Fine. So this will be what? T cos of 30, right? We did it in the previous class in vectors. And this will be T sin 30, isn't it? Right? But you need to understand, how do you agree that this body has a mass, weight, which is downwards, mg? Yes? Isn't it? The weight is downwards. So when this body was, this is positively charged, this is negatively charged. They want to attract. The distance is r. Okay, the distance is r. So when this body deflects, it stays here. So it is in equilibrium. So when this body is in equilibrium, means it doesn't want to go up, it doesn't want to go down, it doesn't want to go right, it doesn't want to go left. So that means this force between these two will be equal to T sin theta. And the force between these two are equal, isn't it? Mg will be equal to T cos theta. Is that fine? Yeah, you find T cos theta, you find T sin theta equated to this, and then you find M. Because you just have to find the mass. You have to find M. Is that fine? Try to solve this question at your places, and tomorrow we'll be starting with the same. Is that fine? So I will maybe write the equation. I'll say that T sin theta is equal to T sin theta is equal to the force of attraction, isn't it? The attractive force between the two, because that force tries to pull it here, right? So that force is how much? You know that is gamma. We know the value of gamma. Q1, Q2, we know 70 and 80, negative 80. So you put in the values here. So I'll just write Q1, Q2 upon distance square. Is that fine? And T cos theta will be equal to NG. T cos theta will be equal to mg. So you try to equate the two, divide them, you will find tan 30, you will also find r, you will find m, try to find the distance and the mass. Is that fine? These are the two equations that you get. Is it clear? So I am doing electrostatics. After this, we'll shift to electrodynamics, that is current, and then we can go to magnetics. That's fine. First, you need to understand this. This is very important. Okay? Click the picture of this question as well. There are three charges, you have to calculate the net force. Use the principle of superposition. Yeah, you take the absolute value because the negative gives you the direction, and you know the direction is like this, right? You don't need to take the negative. Okay, tomorrow we'll do with electric fields, but solve these questions. Okay? Okay, thank you so much.